Welcome to Vidyotma Physics. In next few minutes, I am going to discuss all type of questions and concept related to charged pendulum. Okay, what is value of this theta in equilibrium? How can we find tension in the string? How this theta depends on mass and charge? And finally, we will see what happens if this entire system is dipped inside a liquid. Then we will solve some quality questions. Let us begin and understand the basic derivation. So first, what we have is, this is an insulating thread, okay, and a charge plus Q having mass M is connected to it. If we apply electric field, what will happen? Sir, after application of electric field, the charge will deviate in the direction of electric field. Yes, positive charge in the direction of electric field. So will this charge keep on deviating? No, it has to stop because there are other forces like tension and gravity to stop the charge. Okay, so what will happen? The charge will attain equilibrium, and we have to find what is value of theta and tension in equilibrium. So first, what we will do is standard procedure. Let us mark forces. What are the forces? So this is my tension force, right? After that, gravity is also there, vertically downwards. Then electric force is also here in horizontal direction. Let us name them. So this is my tension T. This is electrostatic force, which I can write it simply as QE. Okay. Then mg. What we will do is, we will resolve the forces so that we can get proper equations or relations. Okay, so how to resolve it? Horizontal and vertical resolution we will do. So if this is theta, this is theta. Yes, why? Sir, alternate angle, sir. Simple. So tension T, so here vertical component of tension is what? T cos theta. And what is horizontal component? Sir, T sin theta. Beautiful. So can I say that in equilibrium, horizontal and vertical forces are balanced? Correct. In equilibrium, vertical forces for equation, if I write, what I will get? Sir, upward force is T cos theta. And what is downward force? mg. So this is equation number 1. Another equation we will get. Horizontal forces we will balance. So we will get T sin theta is equal to, what is T sin theta is equal to? QE, or electric force. This is equation number 2. Now in order to get theta, what we will do is, we will divide this equation 2 by 1. So I will write here equation number 2 divided by equation number 1. What we will get? So 2 divided by 1, if we do, tension and tension will be cancelled. Here sin by cos will be there. So sin theta by cos theta in LHS we will get, which is equal to tan theta. And sir, in RHS what we will get? QE upon mg. This is very, very important formula which we have got. You have to remember this formula. Tan theta is equal to QE upon mg, because many questions come from that. I will tell you what is application of this. Sir, another task is there. What is another task? To calculate tension. So we will calculate tension, don't worry, but let me speak regarding this theta, because questions are directly asked from here. Some cases we will discuss. Okay, you tell me, if electric field is, let us say, 0, what happens? Sir, if electric field is 0, so the electric force will not be there, right? In vertical there is a balance, but horizontal no balance is there. So this pendulum will swing. Okay, so will it come at rest at this point? No, no, no. It will keep on swinging because it has inertia of motion, right? So I will say, if electric field is equal to 0, pendulum oscillates. Directly they can ask questions in your exam. Okay, another important case, what happens if I put this pendulum in a gravity free space? That means if gravity is equal to 0, what will happen, sir? You tell me, if gravity is equal to 0, this term will become infinite. Correct. Here it is 0, the numerator upon 0 is what? Infinite. Tan theta is equal to infinite means theta is equal to how much? 90 degree. That means instead like this, if gravity is not there, then pendulum will look like this. Okay, horizontal. 90 degree angle means what? This is my theta which is less than 90. 90 means like this. Okay, this is the case for 90. Are you getting it? So I will say pendulum will become, very important cases, okay, horizontal. So two cases are clear, sir. Basic, we are starting from very basic. What next? Now I want to understand how to calculate this tension. So let us calculate this tension, and for calculation of tension I will tell you one simple thing. Very simple, no need to square and everything, very simple thing I will tell. See, we have resolved tension in components, right? So for a moment what I will do, I will not resolve it. Okay, forget about resolution. Simply I know that tension is there, and this is an electrostatic force and this is mg force. Is my particle in equilibrium, charge in equilibrium? Yes sir, absolutely it is in equilibrium. You tell me what is resultant of these two forces. The resultant of these two forces will be along this line. 100% it has to be along this line. Okay, so let us say this is nothing but what? Two perpendicular forces are there. What is their resultant? Scalar vector basic. Two vectors are perpendicular. Resultant is under root of a square plus b square. So can I write here mg square plus qe square? 100%. You will ask, sir, why this resultant is along the tension? It has to be, else particle will not be in equilibrium. I am checking equilibrium in this direction along the string. Are you getting it? So directly I can say for equilibrium along string. See, it's my wish to apply equilibrium in any direction I can apply. Okay, it is my wish, my rule. Okay, so along string I can say tension is equal to under root of qe square plus mg square. I want you to remember this formula. Will you remember? Absolutely sir, because there you in exam you will not keep deriving it. See this, pause the video and see this slide once again. We have derived two important equations. Are you getting it? Remember that tan theta is equal to qe upon mg. I can also, by the way, I can also write tan theta as tan theta is also equal to Fe by mg. I will use this as a shortcut. So what is Fe? It is simply electrostatic force. Are you getting it? So let's move. And now this is case number 2. Have you seen this? Yes sir. We are here for the same case. Yeah. Now initially what happens? So I am assuming Q1 and Q2 are both are positive or same nature. Okay. So initially they are tied with the help of two different strings at t is equal to 0. When they are released, so there will be repulsion, and the arrangement will be like this. So let us say the equilibrium separation between them is r. Okay, and I will take this as theta 1 and another angle with vertical as theta 2. Sir, is theta 1 equal to theta 2? When it is equal, when it is not equal, that only I am going to derive now. Okay, are we going to do entire derivation again? No, we are not going to do, because we have shortcut. I will tell you. First you tell me what formula we have written for tan theta. That beautiful formula I want. Sir, that beautiful formula is tan theta is equal to electrostatic force upon mg. You focus on this charge. Focus on this charge. Let us say for Q1. Who is stopping this Q1? What I am saying is, what makes this Q1 hang to the string? Why it is not oscillating? Electric field of this or electric force of Q2, correct? So can I say that Fe is nothing but electrostatic force between the charges? Are you getting what I am trying to say? See, I will write. First what we will do, first I will write expression for electrostatic force. There what was electrostatic force? Q into electric field. Here what is electrostatic force? Sir, for both the charges, electrostatic force is what? K times Q1 Q2 upon R square. Beautiful expression. Is it beautiful? Yes sir, very beautiful. Then what I will write now, very important, we are going to write. Okay, Pay attention. I hope you are paying attention. One thing, for Q1, now I am not assuming that masses are equal. Okay, so let us say mass of first charge is m1 and mass of second charge is m2. You tell me for Q1 what I can write for equilibrium. Sir, you can write that tan theta 1 is equal to k times Fe upon mg, right? So k Q1 Q2 upon r square, and what is mass of Q1? m1g. Hey, are you getting what I have done? I have simply written electrostatic force. Are you getting it? Yes, sir. Can I write for Q2? For Q2, sir, please write it for Q2. Similarly, I will write for Q2 as tan theta 2 is equal to k Q1 Q2 upon r square m2g. You tell me, does the angle depends? Angle depends on what? This theta 1 and theta 2. Whatever angle that charges make with vertical depends on what? It depends on two things, product of charges and mass. I will directly write. Let me write theta. Now for both I am writing. Okay, I will write theta, or let us say, if tan theta is proportional, anyway theta is proportional. Okay, theta is directly proportional to Q1 Q2 and inversely proportional to what? Theta is inversely proportional to mass. That means if mass is more, then angle is less, and if the product of charges is more, the angle is more. This is very basic, but one important condition now that I am going to tell. What we will do is, let us say this is equation number 1 and this is equation number 2. Divide 1 and 2. Okay, 1 divided by 2, what I will get? So sir, 1 by 2 you will get as tan theta 1. Very, very important. You don't understand importance of this. Okay, tan theta 1 upon tan theta 2. Is k q1 q2 cancel? Yes sir, k q1 q2 is cancelled. So cancel, r square is also cancelled. What is remaining is g is also cancelled. m1 m2 remains, but it is inversely proportional, right? Tan theta 1 is inversely proportional to m1, so m1 has to come in denominator and m2 is in what? Numerator. Now if you don't know division, go back to class 8. Okay, I hope you know division. So one thing very important, what? This ratio, that is tan theta 1 upon tan theta 2, this does not depend, does not depend on Q1 Q2. What I am saying? Individual, see what I am saying is, if Q1 Q2 is increased, then both angles will increase because Q1 Q2 is in numerator of both the angles. Are you getting it? But which angle will be greater? If there is a competition between Q1 and Q2, whose angle will be greater? That will only depend on what? Mass. So theta 1 will be greater, inversely proportional to mass. So theta 1 will be greater when m1 is less. So I will say that, what is meaning of this? Let me write with a color marker. m1 greater than m2. If this is the case, then theta 2 is greater than theta 1. More mass, less angle, more mass, less angle, more mass, less angle. Okay, then sir, if m2 greater than m1, theta 1 greater than theta 2. You got the difference? If there is a competition, if someone asks which angle is greater amongst the two, that only depends on what? Mass. Lesser is the mass. So have we written correctly? Definitely. So if m1 is greater than m2, this angle will be more. This is very, very important slide. Okay, pause this and see entire derivation. Whatever I have told you, pause this and see, because this is third condition, sir. Do you know this condition? Yes sir. 3 conditions I am going to discuss. This is last condition. First, what we have seen first, simply first single pendulum was there and QE was the field, or the force was, this system is in electric field. Like here, instead of electric field, what we have done, we have brought another charge. So now force is what? K q1 q2 upon r square. And here what happens if we dip entire system inside the liquid. Now here what I am assuming is sigma is what? Density of liquid. Okay, this is liquid density. What I will take? Density of this mass, okay, this charge. Now we have taken angle as equal because masses I have taken equal. Are you getting it? When masses are equal, angle are equal. So for simple derivation I have done here, m1 and m2 are equal, so that's why theta is equal. Okay, so density of m, let us say it is rho. Nothing we have to do, please have patience. First you tell me what happens here. Technically what happens? Sir, technically only one thing will happen, that here only buoyant force will be there. Do you know what is buoyant force, by the way? If fluid mechanics is done, you may know it, or if it is not done, then I will tell you. So buoyant force or upthrust, Archimedes principle, okay, you only remember that Archimedes ran away, but what is the formula for buoyant force? That you don't know. Okay, sir, buoyant force formula is nothing but volume. So here entire volume of this mass is inside the liquid. Okay, volume into density. Density of what? Density of liquid. So here what is density of liquid? Density of liquid is sigma into G. So this is expression for buoyant force. If fluid is not done, it's okay, you just note this formula. Now I will simply apply our golden formula. Sir, what is our golden formula, sir? That was tan theta is equal to QE or FE upon mg. Yes sir, that was the case. But here you tell me one thing. Here only mg will come or something else will come? My dear students, this is buoyant force. This is mg force. What we want? Vertical force, right? Vertical force. Tan theta is what? Height upon base or whatever, whenever we have derived in that. I want net downward force. So can I simply write this as, I will forget buoyant force. What I will do? I will just write this as mg minus b. Can we do it? Yes, simply we can do it. So what I am saying is, here you can write mg minus b. What I have changed only denominator. Why, sir? Because there was upward force. I don't want. So this is easy to understand. Okay, instead of lot of derivation, this is the easy method to understand. So Fe upon mg minus b. Okay, sir, just you have taken buoyant force downward and this expression came. Then what I can write? Tan theta is equal to, what is Fe? Fe, let it be, we will expand it later, divided by mg. Now what mg I can write? Mass. Now weight can be written as mg, no problem, sir. And mass is nothing but what? Density into volume. You know that mass is density into volume, 100%, sir. So can I write volume into density into g? Volume into density is what? Mass only, na? Mass of the charge, correct? Yes sir, 100% correct. So let me write V rho g minus what is buoyant force? Sir, it is V sigma g. Now very important formula I am coming. Okay, so tan theta is equal to Fe upon, can I take V rho g outside? Yes sir, you can take V rho g outside. I am taking V rho g outside the bracket. Okay, mathematics, please pay attention now. So V rho g if I take outside, what remains here? Only one remains, minus, and this V rho g will come in division, right? So can I write V sigma g divided by V rho g? 100%, sir. V cancel, G cancel, and I am getting to one golden formula. Tan theta, if the formula is golden, we have to write, where I will write? I will write at the top because it is important. Okay, so here I will write final formula. Tan theta is equal to, you tell me, this is what? Fe in division. What is V rho g? What is V rho g? Just I have written V rho g is what? Mg, correct? So Fe divided by mg in bracket 1 minus sigma upon rho. This is the formula for angle. Okay, this is how angle is changed when you dip this entire arrangement inside a liquid. Are you getting it? So you must remember formula same. See, Fe upon mg is as it is, no change in that. 1 minus sigma by rho. Sigma is what? Density of liquid, and rho is what? Density of charge. So density comes in, liquid comes in numerator, charge comes in denominator. Same it with 2 times. Liquid comes in numerator, charge comes in denominator. Liquid comes in numerator, charge comes in denominator. Beautiful. So finally we have arrived Three cases we have known, right? Now let us start with numericals. Are you ready? Yes sir, I am ready sir, with pen and paper. Okay, a charge pendulum of mass m and charge q is in equilibrium under the influence of electric field E and gravity. Both q and E are doubled. What they are saying? Q and E are doubled. Sir, which formula to use? If liquid is there, third formula. If two charges are there, second formula. And if only one charge is there, first formula. Okay, they are doubled. What happens to angle? Okay, a charge pendulum is there of mass m and charge q. Single is there, so can I write tan theta is equal to QE upon mg? Beautiful. What they are saying now? They are saying that q and E are doubled. Both q and E are doubled. What happens to the angle? Okay, now you tell me one thing. If q and E are doubled, okay, here instead of q and E, I think the correct question is, wait, here it must be q and, I will change the question a bit, q and G are doubled. If the question was E was double, I also tell you the answer. So q and G are doubled. So if q and G are doubled, what will happen? So instead of q, I will write now 2q, and instead of G, I will write at 2G. So again, my new angle will be what? Tan theta dash is equal to, right here as 2QE upon m into 2G. No change. Is there any change? No sir. QE upon mg, same thing. That means angle remains same. Are you getting it? Is it simple? But sir, what if electric field was doubled? See, if electric field is also doubled and charge is also doubled, theta will not become 4 times. Tan theta will become 4 times. Are you getting it? If theta is 4 times, that does not mean tan theta becomes 4 times. Okay. Okay. Let's see next question. What is next question? Now this is the question. You have to tell me which is the correct option. Pause and tell the answer. Okay. Are you ready? If you have given this answer correctly, then you are going very right in preparation. If not, then we'll see how to do it. First, you tell me this is my theta 1, okay, and this is my theta 2. Fine. Which angle is more? Tell me, sir. Obviously, by observation, we can say theta 2 is greater than theta 1. If angle is more, that means mass is less. So I will say what? M1 is greater than M2. Are you getting it? Because theta 2 is more, this angle is more, so this mass is less and this mass is heavier. So I can say that M1 greater than M2, which is the option? So A can be the option or C can be the option. B is eliminated. None is also there in the option, okay? So either A is there or C is there. What can I comment about charges? See, in this arrangement, what I can comment about charges? Are charges equal? Or Q1 greater than Q2? Or Q2 greater than Q1? You tell me in entire thing, what you can see? Sir, only angles. Only angles that here the angle with vertical by Q2 is more and Q1 is less. But angle depends. I told you earlier also, angle, when there is a competition between the two charges, angle depends only on what? Mass. It does not depend on Q1, Q2. That means we cannot tell any relation between Q1, Q2. Hey, you take any case. If I take charges as equal, then also same answer will be there. If I take Q1 greater than Q2, same answer. Q2 greater than Q1, same answer. That means same diagram will be there. So what is the correct answer? D. Are you getting it? So maybe you have ticked this A. If I am correct, you have ticked A or C. Okay. If you have ticked D, very good, very good. Okay. Let's see another question. This question was asked in NEET. Okay. In which year, sir? 2013. What they are saying? So actually these are two pith balls. Pith balls are there carrying equal charges and they are suspended. Okay. So this is their separation in equilibrium. Initially the height was y. Okay. In second case, what they have done is they are rigidly clamped half the height. That means they have taken this point, they are shifting this point little bit downward, and now new height is how much? Y by 2. So if this is y, this is y by 2. And what they are asking is that what is the equilibrium separation between the balls? That means this new equilibrium separation, let us say this is r dash, that is being asked. Now if in such questions, if you try to resolve and you get the forces, anyway you will get answer at the end. But in exam time, it will be difficult, right? So I will tell you one shortcut. What shortcut is there, sir? Simply one important formula is there for this. What is that formula? Tan theta is equal to K Q1 Q2 upon R square mg. Have we seen this formula? Yes, sir. Okay. Now one thing, what is different? What will be different for 2? See, different for 2 will be theta. Why theta will be different? Because R is different. See, first K, Q1, Q2, M and G. These are what? These are same for 2 charges. Same for 2 charges. Why? They are identical. It is given in the question. Okay. What is different is this R square is different. And if R is different or the separation is different, that means theta is also different. So can I say that? Can I say that tan theta 1 upon tan theta 2, very important, is equal to R2 square by R1 square? Sir, from where you are getting this? See, tan theta is inversely proportional to R square. If tan theta is inversely proportional to R square, so can I write numerator upon denominator, and inversely means this for theta 1, tan theta 1 R1 will be downside and tan theta 2 R2 will be upside. Another important thing, can you tell me what is, or what we will do? We will arrange this. R1 square tan theta 1 is equal to R2 square tan theta 2. Can you tell me from this triangle what is tan theta? Sir, tan theta is nothing but height upon base. This is theta, that means this is height and this is base, right? What if this is R, if complete is R, this is R by 2. Absolutely, sir, R by 2. So height upon base, so what it will be? R by 2y. Let me write R1 square into R1 divided by 2y. Beautiful. Okay. Here R2 square, similarly what I can write? Tan theta 2. Sir, in tan theta 2, if this is R, so we have taken this as, let us say this is R2, this is R2, that means this distance is R2 by 2. So I will write R2 by 2. Okay. And what is height here? Sir, height here is what? Y by 2. See, this is height and Y by 2 is what? Sorry, base. This is my theta 2. So I will write here Y by 2. 2 and 2 is cancelled. Okay. What remains is, even sir, Y and Y is cancelled. Yes. R1 cube, where to write? So here I will write R1 cube must be equal to, this 2 will come here, okay, 2 times R2 cube. If I take cube root to both the sides, what I will get? R1 is equal to 2 to the power 1 by 3 R2, or I can say that R2 is equal to R1 divided by 2 to the power 1 by 3. Which is the answer? Where is the answer? So here the options are actually repeated. This is correct answer. Okay. Here the option must be in B. It is not printed. I will tell you. It is R upon 2 to the power 1 by 3. Are you getting it? What we did? Simply we have applied tan theta formula. Okay. So with tan theta formula we have solved complete thing. Here in calculation you must pay attention. Here 2y is there. Why 2y is there, sir? Because this is R1 upon 2. R1 upon 2, height upon base. That's why R1 upon 2y. And on this side, height is what? R2 dash upon 2 divided by y by 2. That's why 2 is cancelled. Are you getting it? So keep studying. All the best.